Jordi Deu-Pons is going to introduce us to the Jupyter notebooks running in a Docker Swarm cloud. So, thank you.
Okay, thank you. It's okay, can you hear me? Yes? Perfect. So welcome everybody. Thanks to be here. No, first I'm Jordi. I'm working in a research group that it's in the IRB Barcelona genomic lab. We work with genomic data, and this is why I have put this here, no? Because it's the only relation with the talk that I have put this DNA double helix here, but the rest of the talk has nothing related with genomics. It's just that I will explain our setup, and not only this, you will see, but that we are using in our research group. That it's a group of, we are 16, but using the cluster 12 person, just to clarify. So, okay, it's 3 o'clock, no, it's Saturday. At least for me, it's my siesta and coffee time. I didn't have time for coffee, but so import a bit of coffee just for all of you. So let's start. Okay. So then maybe. So first, a bit what is about this talk. It's first because you will see that at some point is like a workaround solution, the thing that we have been done, that we are using. So then to make this more useful for you, the talk, but even if it's recorded in 1 year, maybe the solution is useless. I will try to introduce a bit the architecture of the Jupyter and to give you an overview of different solutions, and more or less when we want to run notebooks remotely in a cluster, what we can do. So this, the first 2 points, then I will explain a bit very quickly the Jupyter Hub, how it works, and then our alternative solution that we are using to avoid one problem that I will explain. And there's the pros and cons, and at the end I would like to think, I will give my ideas, the things that I would like in a future to implement in our solution, or in general the Jupyter that I would like that it will have, or some combinations with Docker, you will see. Just to, and then it will be also nice if some of you want to add something in this future view at the end or whatever. So let's start. First, this is the main components. So we have the kernel, the IPython kernel, that it comes from the IPython console, but now it's like an interface. So as you may know that we have several implementations with several languages. But the kernel itself, it's this interface that it's quite simple. This is why it makes this interface very powerful. Know that it uses a messages 0 MQ message system. So at the end, the kernel will receive, I think it's 4 sockets or something like this. There is one socket where you can send the command that you want your kernel to execute. Another socket that is more to send like commands to control the kernel, like when you kill the kernel, that you want to stop this, goes through this socket. What else? Then there is a heartbeat socket, so just to test if the kernel is alive. And then another important to know how it works is like the output socket. So the kernel will run, and when the kernel gets the output from the standard output or the standard error or some exceptions, it will broadcast that output to all the clients that are listening to the kernel. So the idea is that the kernel, it will broadcast, and someone has to take care about this. And who is taking care about this output that is generating your kernel? That is when you are running a cell. Is the notebook server. The notebook server, it's like when you run Jupyter notebook, it's like the web service that you are starting. What it will do, this notebook server, it's forwarding this output to the client, that it's the browser, and will be the browser that it will put this output in your cell in the notebook. That means that it's the browser itself who is taking care of the status of the state of your notebook. So when you get, so that means that the kernel generates this broadcast, this output, it goes forwarding through the server and it gets your browser, and then you know that the notebook is periodically storing your notebook. That means that it goes again from all this status that you have on memory on your browser, it goes back to the server, and then it's the server that it stores to the file. So you see, no, this it's simple, it's okay, no. So then it's the normal the normal thing, how it works. This iteration, it's all the time like this. This is more an overview of different, more detailed with all the components. Now, more or less, it's like down you have the kernel, the middle this the notebook server, that is the Jupyter core, Jupyter client. The ND format module is the one that it takes care to store the notebook to a file. Then you can have several clients on top of it. One is the browser, the notebook that we know. There is also the NB convert, that it's just converting the format into HTML, for example, your notebook. And then from here, this slide, it's interesting, the top part. It's different options that you have when you want to have a server that it will start many notebooks, to how to control all of them. For example, this is Jupyter Hub that I will explain a bit more in later. That is when you want to authenticate the users. Then is the TMPNB. This one, it's like, I think, the one that is using mybinder.net, mybinder.net. That it's that when it will start an anonymously session. No, it will start one Jupyter notebook, it will run, and when the session it closes, it stops the notebook. So it's like a temporary notebook where you can run one. And then the other one is I haven't used it. It's for like do some kind of more exams for a student like this. So, and the last one, maybe you also know, it's like just a viewer. So it will convert using the NB convert to HTML, and it will present you the notebooks as an HTML. So all this is, I want you to have this overview of how all these things work. Because now I thought, what do I want when I want to run for our users, for the people in my lab, when we want to use notebooks in a cluster. So first, I need an entry point. So that means that it's a service that it will proxy the request. So further, it may have several notebooks running. So we want someone that proxies the request to all the other notebooks. Then we want to authenticate the users. We also want some kind of central management. We would like to be able to share with other users our notebooks, the ones that are running, or new ones, even if to start a notebook that we have done. We would like this one that it's real-time collaborative notebook editing. So that means, for me, this means like when you are editing a Google Drive document, that you can see in real time what are the other users doing. This it's like what I would like, no? It's like all this list. And as the last point, I also want that my users can start running something, and then they keep that running. They can close their laptops, their browser, whatever, and they can come back no, and they have everything there running, still running without any problem. This last point is what I found that it was problematic. And I started to look for a solution. It was problematic. Why? I don't know if you have experienced that, but if you start running a very long cell that it will take a lot of time, and you are interested in getting the output, but because I didn't tell you, but our setup is that we are working always with laptops, and we go and connect to our clusters. So then we want to be able to close our browser, our laptop, go home, and then at night check it, no? But with the long-running cells, we have the problem that because that thing that I told you before, that it's the browser itself who is keeping the status of your document, we were losing the cell output. The process was still running because it's running in the kernel, and we can do some kind of workarounds to check if the process has finished. But the thing is that it's not quite easy, it's not straightforward, and also that in our lab we have not only computer science, we also have physicians from biology, many backgrounds that they don't want to care about these things. They want the things to work and as expected, and that's all. The interesting thing is that I was not alone, because I thought first, okay, there might be some kind of solution to this, because I found we want to run very long jobs in our cells in the notebook. And in fact, there are several issues in the GitHub for the project Jupyter. Most of them are already closed. I found one that it's still open, no, and they are like cross-referencing. The thing is more, if you have read the second part, it's like they say, okay, also they would like to have this implemented, but I think that it's like it's complex in some way. So they say it has been planned for ages to implement this. So it's something that at some point it will works, like because will be the notebooks, the Jupyter server who will be keeping the status of the document, or in some other ways. I don't know. I also want to say that I'm not a Jupyter developer. In fact, I have been only developing in Python last 3 years, something like this. So I'm not really an expert. But the idea is that we are in this point. So what was the possible solution? Oh, no, sorry, still not. This is like the good solution. So if you want to set up this, like for example, it depends on the case, but if you are doing a workshop and you want your students to be able to run a Jupyter notebook, then go and use this. It's like it will authenticate your users, it will start the notebooks without any problem. The only problem is this thing that the long-running jobs, you will still have this problem that you will have to, if you have a workstation and you start your notebooks in your workstation, then it's not that problem. You keep the workstation working all the night, and that's it. So then, the solution that I test, it was a combination using Docker Swarm cluster. This is not exclusive of this solution. Also with Jupyter Hub, you can run the notebooks in a Swarm. But the thing is that I did a container, an image of Docker, that it integrates a remote desktop server, that is VNC server, with the browser itself and the Jupyter. So it means that the browser is running next to the Jupyter. So it's keeping the status there. And then I use the Apache Guacamole. So it's like just a gateway for remote desktops. I know I will pass very quickly to some scripts, so how it's implemented. It's already in this GitHub repository. I have done like here you can emulate everything in a VirtualBox. So just don't worry about the code, because it's just to explain how it works more or less. I don't want to go in deep detail then if you have any question. So first, I don't know who has an idea. I would like to know who has an idea of what is more or less a Docker. Okay, near everybody. So that's, I wasn't expecting to be in the expert track. So okay, so for the ones that you don't know, Docker, it's just, I would say, like a suite of tools. I would say, like it works. It helps you to work in a very friendly way with containers. This is Docker. And then what is a container? A container is some way that you can run processes in a very isolated way. So that means that you will be able to limit your process. What is the file system that they can see, how many memory they can use, how many CPU, things like this. So this is the idea of the Docker and containers for those of you that didn't know. So then the cluster, the swarm. The swarm is just the name of how they call in Docker the cluster. So for example, in this example that it's in the scripts in the repository, the first lines, you will see it's very easy to create and emulate. You only need to install VirtualBox and then Docker machine. And the first 3 lines, you are creating like a cluster in your laptop. And the other part, it applies exactly the same if you are doing this in a real cluster with real machines. So the first step is you just need to initialize the manager of the cluster. You can have more than one. It works. The manager, they cooperate with a consensus protocol. And then for the rest of the nodes, you just need to do this swarm join with the token and the IP of the manager. And that's it. You have the cluster. So when you run a new service or new container in your cluster, it can run anywhere in the cluster. And here it's more the example how then I set up the things. First, I create 2 virtual networks inside the cluster. One is the proxy network, that is just because I always want to map any service that I have to a single URL. So all of them to be able, for example, if I have 2 services running different containers, port 18, I can map them to 2 different URLs. So this is why I use this network, and also you will see the first stack here. And the second network, the notebooks, is the one that I will connect all the netbooks so they can interact with the Apache Guacamole. That is the one who is going to serve the desktop view of my Jupyter containers. And like this, I start this different stack. A stack is like a group of services, that a service is like a container. So it's a very simple way to define a set of services that you want to run. I run the proxy, I run the Guacamole, and I run the registry. So here it's an example of this image. This is how in Docker you can specify what do you want to run inside that container. This is the most interesting part of this project. It's that how I create this image, that I start installing only the VNC server, the Firefox, and you see here that I'm installing Miniconda down there. So that's how I set up this image, that it will be able to run many containers. And then we have for each user to be able to customize their own image if they need something else or different, or at least I don't want to run the containers as root and change the user ID, so I have one different image for each user. This is doable because we are only 12. So I mean, if you want to do this for more users, that's not the way to go. There are other better solutions. And the last step is just to set up the configuration of that running container to say what folders will be able to run So normally this is pointing to the project folder where we have our project with the code, the IPython notebooks itself, and the Python scripts. Also, you can see because there is a conda installed, and then it's also important to define the path to the conda where it will have the environments. So then the end user can install anything, an environment inside this folder that it's a network file system folder. So we keep the environments next to the project. That's the idea behind this. Then, well, for this, we have an automatic script to do these 2 steps. But just to clarify, then you need to configure the connection in Guacamole. And then Guacamole, you get something like this. You can see you're running the notebooks that you are running here where it says project. But because it's a platform, a web platform for remote desktop access, you can have other things. That's like, in this way, it's a bit more generic solution. And for example, we can have access to a Windows, no? Because we are working with Linux, but sometimes we still need to go and do something with Office. This was just to illustrate that you can do other things. And this is like how it looks like. It's like a browser inside a browser. I was impressed that it's working very well. I was expecting more delay, and it works very well. This Guacamole project, it's still an incubator project in Apache, but it's really, really good. I was impressed about this. Even I compared with some remote desktops clients that I have installed in my machine, and this one that is going through the browser, it's better. It gives us another solution. I mean, this is like a workaround, no? Because I would like to be able to run long cells without any problem directly in the Jupyter. And also, I will like this real-time editing capability. And with this solution, we also get this in some way, because Apache Guacamole gives you the option to share your connection, your screen. So you can share in 2 ways, with full access or only read access. The full access, it means that you will send this link to the other, to who you want to share with, and it will be able to connect and control also the mouse and the keyboard. So it can, for example, help you doing something. But the thing is, it's real time, because you can be in the Hangout talking or with the Skype, and then the other can also interact. But it's like you have to fight for the keyboard, no? It's only one at a time. It's like a walkie-talkie sharing your notebook. But it's useful. It's useful because in our group we have different backgrounds, and it's very useful sometimes to be able to help anyone in the group that they told me, okay, this is not working, can you give it a look or what? Just share me the link and I will go there with no problem. I will see exactly the same. In fact, they will see what I'm doing. So even if we are not in the same office, it's very useful for help or interact with someone else in a notebook. So, okay. What about pros and cons of this setup? As I told you, it's a workaround, and there is the Jupyter Hub, that it's a very good solution, and I say that you have to try Jupyter Hub. It's also, in many cases, even better than this, maybe. But this has some advantages, that it's like this one, the main that we want, that you can disconnect at any time. So it's because we have the browser inside the container, we are not going to lose never the status. This was the main reason we did that. Then, as a collateral effect, we get this kind of concurrent notebook editing. We weren't looking for that, but it's also useful. And then another thing is that you have an entry point where you can have anything, not only Jupyter notebooks. If we need to have one machine with Inkscape with a lot of memory, we can have there, and the user, they go to exactly the same entry point, and they access our machine that has an Inkscape that needs a lot of memory, and they can use that tool. And with this, I can imagine many other situations. Cons, things that are not, that I don't like, you know? The copy and paste, because of the browser itself, it's not allowed to share the clipboard of the user. So it's like indirect. From inside the container, you have to copy. It will appear in a lateral box that you can open, and then from there you copy to your host. The scrolling, when you work with the Jupyter, it works perfectly. The only thing that you notice is when you scroll. When you scroll, then you can see a bit of delay. But still, it's quite useful. It's not a problem. Then the last one is not really a con, it's just the look and feel. It's a bit strange sometimes, because you have a browser inside a browser, and maybe the look and feel of both is different, but you can put in full screen the host browser, and then it looks like you were inside. So now I have 3 slides about the future. This one is more about things that maybe we can do to improve our solution, that I would like to add a graphical interface to be able to, instead of having a script to create the notebooks, to be more graphical. For this, maybe I will have 2 solutions. One solution, because Jupyter Hub can also run containers, why not? And at the end, Guacamole, it gives you a URL where you can connect. Maybe it's possible to integrate this inside the Jupyter Hub. Just that the container that it will start, it will be quite different, and it will go through the Apache daemon, the Apache Guacamole daemon. Another option will be the other way. Apache Guacamole, it's not for not only for remote desktop. It's very interesting. For example, they also have SSH protocols, so you can also add connections that are SSH connections, telnet connections. Why not? It's possible to implement like a proxy connection, so that the only thing that it's doing, it's proxying the HTTP and WebSockets to the notebook. Then I will have a norm, like it will be very similar to what it's doing Jupyter Hub, but you also will have the option to have these remote desktop protocols. And the last one, this one is very simple. It's just to add a Jupyter Lab that does the same. This one, that's quite interesting. The real-time collaboration, it's coming in Jupyter. It's coming in Jupyter Lab. They are working on it. I didn't test it. It seems that there is like a first implementation, but the good thing is that this will be very soon available. It will be that they plan to do like first that you will use the Google Drive real-time API if you are running in your laptop and you want to synchronize to share to let someone to edit also in real time, or it will be also more integrated in the Jupyter Hub. So this is a good news that I think that we will also use, but this is still not there. It's a work in progress. And then another thing that I think that it will be very nice in the future, even if we use Guacamole, Jupyter Hub, whatever, but running the notebooks inside a Docker container, is this checkpoint feature that already has Docker, but in the experimental, when you run as experimental the engine. The thing this means is like some kind of hibernation. So when you create the checkpoint, you are like storing the status of the memory of the container, and you are like stopping the container, and you can even move to another host that container and restart there again. Why I think it's very interesting for us, because the notebooks are long-running jobs, long-time-running jobs. So with the traditional cluster that we have both systems, that it's a queue system, that you have a scheduler, then the long-running jobs are not working very, very well, because you always have there, and maybe at some point you need like to stop. But in this way, we can let the users start their notebooks. There is no problem if they have many, but maybe we will say, okay, you can only have 3 running at a time. The other ones, we are going to hibernate your notebooks. Or we are in a hurry and we need more computation for some other thing. We are very sorry, but we are going to start that notebooks of some user, and we are going to give priority to someone else. Or, for example, this notebook is running out of memory, but it has been running for 1 week. What we can do, no? What we can do? We can do it, implement it better, or hibernate that container and start it in another host with more memory. Maybe, because we are a research group and we only want to run many times the thing only once. Maybe if this works, we will do this second option. This is why I wanted to share with you this thing that I think it's coming, and it's very near, and it will be very interesting. So thank you. If you want to add something to this vision or questions or whatever, it will be very interesting. So thank you.
So, any questions? Yeah?
Thank you for the presentation. It's really interesting. I actually used Jupyter Hub and had the same problem as you had, for example, for real-time and collaborative editing. The question I have, and you partially answered it with hibernation, is that normally when you have a Docker container running, it's just for a small process that kills itself at the end of the actual action, right? So I get the point that your browser is in the Docker file, the image itself, so it doesn't kill itself when you log off, but still it means that it keeps running as an image at some point. So that's the first question. Is it really the core of Docker in the first instance? And regarding the data you use in your notebooks, how do you package it? Is it in the image? Is it that heavy, or do you use volumes that you link with the image? Is that clear?
Yeah.
Okay.
The first question, it's about yes, this container running 3 processes. This is not what they want in Docker. They say Docker has to run only, it's the philosophy, it's the perfect way. But I think that near nobody is doing this, so maybe because Docker is more for microservices. We are starting to use Docker in different ways. So yes, I'm running 3 processes, 4 processes in one container. One is the Firefox, the remote server, and the Jupyter itself. And the other one is the supervisor, that is the one that starts all the other 3 processes. That's not a problem. Okay, you are losing some CPU, but it's not a problem. It's stable, and the CPU is very low. And that's another good thing, because sometimes you crash your laptop due to this, or you, without intention, you start printing in your cell like 1 million of rows, and then it crashes your. Now maybe you will crash. If it happens, it will crash the container, or it will. No, it will be more, because we can put limits to the container. That's also interesting. Maybe at the end will be a Docker that will kill or will give less priority to your container because it's using a lot of CPU. And the second, we have in our host servers with network file system the different volumes that we want, and we share this into we share as volumes into, but not mounting using network file system. It's just the normal as when you are doing in your laptop. It's like from the file system.
Hi, thanks for the talk. So if I understand correctly, you're running a virtual machine where you run a browser so that you can, that browser can keep the notebook state. I don't know how that state is represented, maybe some cookies, maybe more, I don't know. Have you considered, to have this on your browser and not on a virtual browser through VNC, have you considered like a headless browser that would keep your state, and then maybe a method to move that state, if it's just cookies, it's not that hard, to your browser so that you can just take over the state and run it on your browser?
Well, the state is more like in memory, I will say. It's like in the HTML 3, no?
Okay. So if you close the tab on your, does the computation stop?
Yeah, it's the same. Just closing the tab.
Oh, so it's not.
So and the other thing is that it's not virtual. It's not it's like Docker. It's not, nothing is virtual. It's not a virtual machine.
Yeah, I know,
but
but
process, but with some restrictions.
No, I was talking about the VNC thing, which it looks a bit cumbersome. It gives
you also a bit of overhead because you also need to to
transmit. I was wondering if you could just run it through something like Phantom.js, which is a headless browser.
Yes, but I guess that the overhead will be the same, and then still you need some kind. I guess that the setup is quite more complex. I cannot imagine. I don't know, but theoretically, a headless browser, it will keep the status. Maybe I don't know. I was also trying without the remote desktop, like directly using the X Windows, but then it's less. When you are in a cluster, this is more dangerous. Maybe for your laptop it's perfect. You can run graphical interfaces inside a container, just mapping the X socket, but in a cluster it's a bit dangerous and less reproducible.
I have one question, a more basic question, but do you have experience running Jupyter Hub, I guess?
I tested. My experience is testing Jupyter Hub more than...
Okay. No, my question was about the performance of Jupyter Hub when compared with Jupyter on local mode. I don't know if you have any benchmarks?
I don't have benchmark, but at the end it's like, it's just a proxy. Jupyter Hub is just forwarding your request to your Jupyter server, the Jupyter notebook that you have. So I mean that what you lose is very, very insignificant. Not like in my solution that you lose some performance because you are doing the remote desktop that you have to share all the screen. So in Jupyter Hub, it's like I will say, if you have everything properly set up, your main server and everything well dimensioned, it's like if you are directly running directly connecting to the Jupyter notebook.
Thanks. More questions?
Once the users start running the process, are they also demanding some sort of alert system that tells them, okay, your process has finished, and they get notified? Like for processes that take 2 days to run, like maybe you are eager to see the results, or the team is eager to see the results, and they say it's ready.
No, the answer is no. And if I do that, it will look like more a magic in the cell. Some kind of maybe it's already done. I don't know if someone knows, but I imagine that you put a magic, that send me a mail, magic, no? On the side, and at the end, it will send you the mail. But I don't know if I had to implement this, I would do in that way. The thing that we have, that we are monitoring our cluster, and we also recollecting the logs of our cluster, but it is more like in a system admin level, no, not for the user.
Is any other question? Okay, so please an applause for Jordi. Thank you, Jordi.